we're back. So one of the topics that's the most challenging in chapter 8/9 is synthesis. And the problem you'll be confronted with is something like this. So here's the problem. Propose a synthesis of the following molecule, this thing here, beginning with bromobenzene, ethane, and methane. So your starting materials are bromobenzene, ethane, just CH3, CH3, and methane, CH4. And you have to take these three and convert them into this tertiary alcohol. So this is the kind of problem that is very intimidating. It's usually worth, 18 points or something on an exam, 16, 18 points. And my connection is crap. Yeah, your Wi-Fi. It told me I had a slow connection for a second, but that message just went away, so maybe, hopefully, Jamie, that'll make it better. And I'm recording it, so I'll post it too. So, sorry, just saw someone was typing, so I interrupted. So here's the problem, right? There's a whole page on the exam. It's worth 18 points, so you know that it's got a lot to it, but the question is really simple. Propose a synthesis of the following molecule beginning with bromobenzene, ethane, and methane. So the question is, how do you even start a problem like that? So there are several reactions that are going to be involved in making this, right? At some point we have to introduce an oxygen atom. So we're going to have to figure out how to introduce an oxygen atom. These are alkanes. And alkanes are useless. So at some point we're going to have to functionalize those alkanes. Right? So we have to figure out how to convert those alkanes from hydrocarbons, which have no polar bonds and therefore really can't do any reactions, into something that can. Right? We know we're forming new carbon-carbon bonds. Right? In fact, we're forming 3 new carbon-carbon bonds. And we have to figure out how to form new carbon-carbon bonds. Right. So the big thing, right? Introducing an oxygen atom somehow, functionalizing the alkanes, forming new carbon-carbon bonds. We have to figure out how we're going to do those 3 things. So how do you introduce oxygen atoms into a molecule that doesn't have any?
You can substitute a haloalkane.
So this is a substitution reaction, right? That's the only way right now that we know for introducing an oxygen atom. So you know there's going to be a substitution reaction somewhere. And if it's a primary carbon that you're substituting on, probably SN2, likely with hydroxide ion. And if it's tertiary carbon, probably SN1, likely with water, right? So one of those 2 reagents, water or hydroxide ion, is likely to be the source of the oxygen in that molecule. How do we functionalize alkanes? You actually only know one way to functionalize alkanes, so that's helpful. You don't have to choose between them. You only have one choice. And the battle with a problem like this, where you've got multiple steps, is doing something, right? Doing the things you know how to do, and then hoping that eventually that leads you to the whole problem. So how do we functionalize an alkane? We've got just a plain old hydrocarbon, and we want something that has polar bonds in it. You only know 3 reactions of alkanes, One of them is combustion. Burning them is not going to be useful in this case because then we'd have CO2 and water. One of them is pyrolysis, which breaks down long chain hydrocarbons into short ones. These are already very short chain hydrocarbons. So pyrolysis isn't going to be useful. What's the only other reaction of alkanes you know?
Free radical halogenation.
That would be the one, right? So we're going to have to do free radical halogenation. That's the way we're going to convert ethane and methane into something we can use. Whether you want chlorine or bromine depends on where you're trying to put that halogen, right? If you're trying to put that halogen on the more substituted carbon, then we want to use bromine. And if we're trying to put the halogen on the less substituted, then we want to use chlorine. And still, we'll probably get a complicated mixture with chlorine, and we'll have to distill them apart. So we'll have to be a little careful, right? Sometimes you can choose, based on which alkane you're working with, whether you can get a good yield with bromine or you can get a less good yield with chlorine. And then we got to form new carbon-carbon bonds. You only know one way right now to form new carbon-carbon bonds. How are we going to form these new carbon-carbon bonds?
Nucleophilic acyl substitution.
Using what? Right, so we know that we're going to form these from nucleophilic acyl substitution.
Organometallics.
Using an organometallic. And what's the other half of a nucleophilic acyl substitution besides the organometallics?
H3O plus aqueous.
That's the second step of the organometallic reaction, but that's not the other reagent.
It's like the diethyl ether.
That's the solvent.
Never mind.
Right? So the organometallic is only compatible with diethyl ether solvent because otherwise it'll deprotonate things. So what are we adding an organometallic reagent to? Bring back the quiz.
Carbonyl group?
A carbonyl group. So then we also have to figure out how to form the organometallic, right? And we have to figure out how to react those organometallics. And to form a carbonyl group, what kind of reaction is going to be involved? So far we have substitution reactions, free radical halogenation, and nucleophilic acyl substitution. Right? Those are the types of reactions that are going to be involved. But how do we make a carbonyl group? Because we're going to need carbonyl groups as half of our nucleophilic acyl substitution.
Oxidation from alcohols.
Oxidation. Right? Forming organometallics is really easy, right? We just react with lithium or magnesium metal from a haloalkane, and then this reaction, right, that's involving ether solvent, and then the aqueous acid workup. So we have 5 types of reactions we're going to be using. Substitution reaction to get the oxygen in there, free radical halogenation to convert these to something useful, nucleophilic acyl substitution to make the CC bonds from organometallics. We're going to make those from alkyl halides, and we're going to form carbonyl groups from alcohols by oxidation. So those are the reactions that are involved, and it's not very many different reactions. So that's kind of nice. So then we have to decide kind of what order we're going to do things in. Now, if you are not quite sure how to analyze that complicated problem, because that's a big molecule and it frightens you, right? Which is a reasonable, in response. Start where you can start, right? We know we have to functionalize methane. Let's functionalize methane. So we'll add bromine and light, and we can convert methane into bromobenzene or bromomethane. And we can functionalize ethane, and it really makes no difference because all of these hydrogens are identical in both of these molecules, whether you use bromine or chlorine, and so we don't have to make that choice. Right? And we're going to make CH3CH2Br. That's got to be worth 2 partial credit points, and all you've done is free radical halogenation on the alkanes that were given in the molecule. We know we're going to have to introduce oxygen, so the next thing to do in this molecule might be to identify where the carbons in the molecule came from. It's probably fairly obvious that these 6 carbons came from bromobenzene. Right, so if we're working backwards, that's where those came from. Where did these 2 come from, and those 2?
The ethane?
From ethane, right? Because those are ethyl groups. And that leaves this one. Where'd that one come from?
Methane?
Right? It's the only kind of carbon by itself. So the oxygen's on the carbon that came from methane. So logically, we want to take this thing, and that's where we want to introduce the oxygen. So how can we introduce oxygen to bromomethane? We're going to want to convert that from bromomethane into methanol. Primary, secondary, tertiary, actually none of the above, right? This is just a methyl, which is even more reactive in SN2 reactions than primary, secondary, or tertiary. So we're just going to use sodium hydroxide, and it doesn't really matter what solvent we want to use here because we don't have to worry about elimination. There are no beta hydrogens because there's no beta carbon. So sodium hydroxide in a polar aprotic solvent, nice SN2 reaction. Okay. We're forming the new carbon-carbon bonds to this carbon, so we're going to have to oxidize that up to methanal, or formaldehyde. Official name, methanal. Common name, formaldehyde. How do we oxidize methanol to formaldehyde?
Oxidation?
Yep, but with which reagent? We gotta be a little careful, right? We want to make sure we don't form carboxylic acids.
It's the PCC.
And the
And
solvent for
CH2Cl2.
Yep, the solvent for PCC is almost always dichloromethane because it's nicely soluble. PCC is a red solid, and it dissolves in dichloromethane, give a dark red solution, so it's handy. So we've got formaldehyde. We now have something that we can form a new CC bond to, but we're going to need an organometallic. The things we're adding are ethyl groups and a phenyl group. Both of those are going to have to be organometallics. So we have bromobenzene. We're going to need to convert that into an organometallic reagent, either an alkyl lithium or an alkyl magnesium bromide. Might as well use the alkyl lithium because that's the one that was on the third question on the quiz. How do you convert bromobenzene into phenyl lithium? And then we're also going to need to convert the bromoethane that we made up here into an organometallic reagent. Let's make this one into the Grignard reagent because that's analogous to the first reaction on the quiz. How do we convert bromoethane into ethyl magnesium bromide? Isabel doesn't have to be the one to always answer it. Or someone who hasn't answered could feel perfectly free. So how do we make organometallic reagents? Well, you're thinking about that. I'm going to go number, right? So there's reaction 1. We had to functionalize the methane. Here's reaction 2. We have to functionalize the ethane. Here are reactions 3 and 4. Right? We introduce the oxygen, and then we oxidize it up to form the carbonyl. And then reactions 5 and 6 in this process are going to be converting the bromobenzene and the bromoethane into the corresponding organometallics. What do you think? How are we going to do that? Any ideas, Aaron?
Would you do something kind of like what we did on the quiz and do like, would you have to do like an E2 reaction?
Actually, there were no examples of converting a halobenzene or a halogenated hydrocarbon into an organometallic on the quiz because I just gave you the organometallic. So what element are you adding here that wasn't there to begin with?
You're adding bromide, or
we have a
you're adding lithium.
You're adding lithium. What's the easiest way to add lithium?
Would it be the lithium and then aluminum H4? I don't know what you would call that.
Just lithium, right?
Just lithium?
Lithium solid.
Oh.
We don't need a hydride reducing agent, right? We're just trying to add lithium, so just solid lithium. And we need to add 2 of them. The other product is going to be lithium bromide. So basically what you're doing is you're exploiting the fact that lithium is an electron donor, right? It really wants to become lithium plus. It's going to donate one of those electrons to bromine to become lithium bromide and the other electron to this carbon to create effectively a negatively charged carbon. So just 2 lithium solid, and the solvent for that should be something inert like ether.
Okay.
What about this one? We're trying to basically insert a magnesium in between the carbon and the bromine.
Would you do the same thing and just add solid magnesium?
You would. Solid magnesium. Again, in some inert solvent. I'll say THF this time just because might as well use it. Yep, so it's easier than you thought it was. Right?
Oh.
Just adding the metal, right? And exploiting the fact that alkali and alkaline earth metals both like to give up their electrons. They're going to give them up to basically this carbon-bromine bond. So, there you go. Not so bad. Thank you. All right, so we've got 6 reactions. Now we have the organometallic reagents. We have phenolithium and we have ethyl magnesium bromide, and we've got formaldehyde. Now we're in position where we can actually form some bonds. And if you look at our original strategy, right, we had to introduce the oxygen atom, which we've done, functionalizing the alkanes, which we've done. We've oxidized, right, to form the carbonyl group, and we've made the organometallic. So we've pretty much done everything except this part involving the nucleophilic acyl substitution reactions. So we're going to have formaldehyde, and we're going to make a new carbon-carbon bond. What would you like to make that new carbon-carbon bond with? What do you think, Cameron? What should I add to formaldehyde? Cameron's sleeping.
Would we add that lithium benzene ring?
Sure. You could add either of the organometallics. Let's add the benzene ring, right? Let's add the phenolithium in ether, which is what we made it in, right? So basically we're just going to take this solution and add it to the formaldehyde. That'll form the new CC bond, and then the aqueous acid workup will protonate it to generate an alcohol. So in this case, we will make benzyl alcohol. So we formed one of the 3 carbon-carbon bonds that we needed to form, right? We formed this one between the benzene ring and what used to be the formaldehyde, or the methanol. So now we have benzyl alcohol. We need to form 2 more carbon-carbon bonds here, right, to there. But right now it's an alcohol, so if we're going to form a new carbon-carbon bond to that, what does it have to be first? Can we form a new carbon-carbon bond to an alcohol? So there's reaction 7 in the pathway, right? Forming one of the new carbon-carbon bonds.
Would we use an organometallic?
We are going to use an organometallic to form a new carbon-carbon bond, but can organometallics react with alcohols? Can you do an SN2 displacement where a negatively charged organometallic carbon kicks out hydroxide ion?
No.
No. Right? Organometallic reagent in presence of an alcohol, all it's going to do is take that hydrogen off because it's a strongly basic reagent. What do we add organometallic reagents to?
Carbonyl groups.
Carbonyl groups. That's not a carbonyl group, but if we're going to form a new carbon-carbon bond, it has to be a carbonyl group. Right? So we got to convert that to a carbonyl group. How are we going to convert that to a carbonyl group? So we're taking the primary alcohol, benzyl alcohol, and what we want is to make it into benzaldehyde.
Oxidation.
Oxidation with what? It's somewhat repetitive.
PCC.
Yep, PCC, got to be PCC, right? Because it's a primary alcohol to an aldehyde. We don't want over-oxidation. So same reaction, right? We convert a new carbon-carbon bond to add an ethyl group. We've actually used every reaction that we know, right, that we identified that we would have to use in this pathway. We're going to form a new carbon-carbon bond, and we're going to convert that aldehyde into the corresponding secondary alcohol. Oops. Messed up that bond. So how do we form that new carbon-carbon bond here? What are we going to add?
Organometallic.
Which organometallic?
The one with the MGBR.
Yep. Right? I arbitrarily made the ethyl group into the magnesium bromide derivative. So THF solvent and then aqueous acid workup. And I made the benzene ring into the organic lithium. It really doesn't matter if you make alkyl lithiums or alkyl magnesium bromides. I just put one example of each on there for fun. But if you like, just make magnesium bromide every time, or make alkyl lithiums every time. So now we've got everything in the molecule that needed to be in the molecule except that third, right, carbon-carbon bond. We've got to add another ethyl group. What are we going to have to do to this thing if we want to make another carbon-carbon bond?
We make another carbonyl group.
And we need it to be a carbonyl group. So we've got to oxidize that secondary alcohol up to a ketone. How? Well, now it doesn't actually matter, right? Because it's a ketone. We could use potassium dichromate and aqueous acid, or we could use PCC again. Either of those reagents is going to accomplish converting that to a ketone. And then we have the ketone, and we want to add another ethyl group, form another carbon-carbon bond. So we're just going to repeat what we did up there. Ethyl magnesium bromide in THF or ether, and then aqueous acid workup, and that will get us all the way to the product that we wanted. So it's 11 steps to get there, which is a little bit intimidating, I think, right? Because that's a lot of reactions, and you kind of have to do everything in the right order. So the battle with a quiz like this is breaking it down into components, kind of the analysis ahead of time, where we decide what all we need to do and figure out how we're going to do each of those things, figure out which carbon-carbon bonds need to be formed, so you can start thinking about how those new carbon-carbon bonds are going to be formed. Right? You could also have worked backwards and said, well, if I wanted to make that new carbon-carbon bond, what would I have needed to start with? Right? So another way to approach the same problem would have been to say, I want to make this new carbon-carbon bond here, right? That's the one I'm going to focus on. What would I have made that from? Well, I would have made that from an organometallic, and I would have needed a ketone that has the other 5 carbons in it. So that's another approach. Right? And then I could have in turn made that ketone from the corresponding secondary alcohol, and then I could have worked backward and said, well, that must have come from, right, an aldehyde plus an organometallic. And then my problem becomes, how do I make that aldehyde, and how do I make that organometallic, and I continue to work backwards. What often works with these problems is a combination of working forwards and working backwards. So you're stuck, you don't really know what to do, at least functionalize your alkanes, right? Introduce an oxygen into something, right? Oxidize it up, right? Make a bunch of molecules that you know you can make, and then see if any of those will get you